guys, one of my viewers asked me the other day if I can do a relative compression test with the OTC-3840 lab scope. It's this unit here. This is a 2-channel lab scope. He's got a MATCO version of this unit, and that's MD4000F. So basically this is a 2-channel lab scope. And we're going to do a compression test with a current clamp and without current clamp. We're going to use a 2-channel. On one channel we're going to look at our current clamp or our voltage drop, and on the second channel we're going to use the second channel as a sink, and we're going to use a sink from coil number 2, and by the way, this is my Chrysler Sebring with the 2.7 V6 engine. So basically, relative compression test, it's done when we are diagnosing a misfire in the engine. As we know, there are 3 reasons why engine can misfire: fuel, compression, or ignition. And relative compression test is going to give us a quick direction where to go if we can rule out a mechanical problems in the engine. So idea behind relative compression test is that when cylinder is going to top dead center and starts to compress a fuel mixture, it creates mechanical resistance. Now, in order to overcome that mechanical resistance, starter needs a amperage. So once that top dead center is reached, the amperage is going to reach its peak as well. Now when a piston goes down, that amperage is going to drop down. So basically it's going to follow the piston and follow the resistance, mechanical resistance. So if we have a healthy engine, each cylinder is going to produce same amount of resistance, basically same amount of compression. So in order to overcome that compression, starter is going to need same amount of amperage. Now if we have a cylinder that has less compression for maybe leaking intake or exhaust valves, or maybe the bad compression rings, that cylinder is going to have a less compression, is going to have less resistance. So therefore there's going to be less amperage needed to overcome that compression, that resistance in the cylinder. Now when we do our relative compression test on the lab scope, we're going to see the peak of each cylinder. And if we have a cylinder that does not have the same compression, that amperage is going to be less. So we'll be able to see that on the lab scope. Now that is if we're using the current clamp. Now if we are, this is the current clamp we're going to use. Now if we don't use a current clamp, we're going to do the same test with by looking at voltage drop. So the idea behind that is basically we're gonna have the same pattern on the lab scope, but the difference is going to be and we have to use AC coupling on the lab scope. So every time when amperage goes up to overcome a mechanical resistance, the voltage is going to drop down, and then we're going to see actually peak of the voltage drop on every cylinder. So if we have a cylinder that has less compression, that's going to be less of the voltage drop needed to overcome that resistance. So that's it. I hope I explained what, but I'm gonna show that on our once we start doing the test itself. So now, in order to do this test, we have to disable ignition or fuel. So basically, we don't want engine to start. We want just engine to crank. And in some cars, we can simply press the accelerator all the way to the floor, and it's gonna get the into the clear flood mode, and engine computer is going to shut down the fuel injectors, and we can crank the engine over. Now, if you cannot do that, now on this car, I'm going to pull my relay, the fuse, the fuel pump relay. I'm going to do it right now. I'm going to let my relay out. It's going to take a minute or so for the engine to burn all the fuel. And then I'll show you the first setting we're going to do without a current claim. So basically now the engine is stumbling a little bit. So here's our setting we have. Okay, so engine is dead right now, so so we can safely crank the engine now. Now, so here's the lab scope. We're going to have two channels. The yellow channels, the yellow lead is my channel A. This black lead, it's aftermarket, but I like it to use because it's longer. This is a channel B. So the yellow lead, it's a channel A, and I'm having it connected to my battery, and this battery is actually under the wheel well. But these are access for my battery posts. So I have my positive lead on the battery positive, and the negative lead on the battery negative for channel A. Okay, for channel B, this is my negative lead. I have it on the battery negative, and my positive lead, I have it I'm back probing a control wire on the injector on the coil number 2. Okay, so this is going to be our sync, and let's do it. Okay, so I'm trying to get my glare off the screen. So right now we have our channel A hooked up to straight to our battery. The positive lead goes to the positive, negative goes to negative. Our channel B, we're going to trigger off our coil number 2. So the positive lead from channel B is going to be, we are back probing the control wire on coil number 2, and the ground wire on our channel B goes to ground, to battery negative. So when we turn this unit on, it's going to flash a little bit, and then and we have to keep it pressed, and it will come on. Okay, so now I'm going to turn the lights on. This yellow button, when you turn the yellow button, it's going to give us a light. So this is the first screen that will that's default. You can change this, but this is what comes from the factory like this. It's default. So the first thing we need to do to do this test is go to menu, and from there we're going to go to instrument setup. Okay, so to do that, I'm just going to scroll. I'm pressing this button, and I'll scroll down to instrument setup, and I'm going to press select. Okay, then we're going to do a display options. Go select, press select again, and then actually, I'm sorry, I don't need to go here. I'm sorry. I'll just go back. I'm going to instrument setup. This is what I want. Okay, here you go. So let's back it up again. I'm sorry, I messed it up. So when you gets to the main menu, this is what we're going to have. From there, we're going to go to instrument setup. I'm going to press select, and then we want to use a filter because there's going to be a lot of noise when we do a relative compression test, and we want to activate a filter on both channels. It's going to give us a better signal on the screen. And I apologize, actually I got this unit like 2 days ago. I'm still learning how to use this one. So go to filter, press select, and then going to input A and input B, and by pressing select we can turn it on and off. So we want to on A, and scroll it down and do again on. It's already been set up, but so that input A and both channels, I like to have it on the filter. Is going to give us a cleaner signal once we do the test. So we're going to press OK, and then we're going to go to scope. Alright, so I'm going to scroll up to a scope setting. I'm going to press select, and now on the scope setting, on the input A for our first test, I'm going to press A. And now when I want to activate channel A, now I can set up my channel. So this so input for channel A. Okay, so I want to do coupling. I want to do AC coupling here. So I'm going to press this number 3 here, and it's going to give me an AC coupling. Now I want to arrange my channel A. So when you this button here, you can move your channel A. You can set your trigger. I'm not going to use the trigger at all. Now go back to range. So my voltage scale on this is going to be 0.1 volts. Okay, so by pressing this upper button, now we can see, I'm not sure if your skimmer is going to pick that up, now we're changing our scale right in here. This is for channel A. Okay, so we're going to go to 0.1, 0.5, 0.2, 0.1, so basically 100 millivolts on AC coupling. That's what I'm going to use for a relative compression test. And my time, I'm going to use a, and this is actually per division. So we got 8 divisions on the voltage scale and 10 division on the time scale. So the next going to be our time, and the time is going to be a 0.1 milliseconds. It's actually I'm going to go to 0.1 seconds. So now I'm going to use these two cursors here, buttons, and I'm saying 2 milliseconds, 5, 10, 20, 50, 0.1 seconds. So so this is my time scale what I'm going to use. Now next I have to set my channel B. So I'm going to go back. So I'm done with the channel A right now. So I'm going back, I'm pressing number 1, and I'm going to input B. Okay, so I'm going to press number 2 again to display. This says display off, and I'm going to display the on. So I turn my channel B on. I'm going to use a DC coupling, so that's good. Now on my voltage scale, now I'm going to use a 5 volts on my channel B. So right now it says input B. So what I'm doing right now, I'm setting my channel B. Okay, so I'm going to increase this to up to 5 volts per division, and you can see now it's changing here. We got 50. Actually, go back. 10, 5 volts right there. Okay, and the time is going to be the same. Okay, so now when I turn the key on, my B channel should register the system voltage. It should be let's say 5, 10, 12 volts. So this is per division. So it should go in this third. I'll turn the key on. There you go. You can see now it's and now the computer turned it off. So basically we are ready to do our first relative compression test, and I'm going to press my accelerator all the way down, and I want my throttle to be open so we can suck as much air as we can into each cylinder as we do the testing. Now with this particular scope, as you do this, you'll have to this is your hold button here. So it's once you start, like you crank it for like 5 seconds, then you have to press hold button, and that's going to freeze up your screen. One thing that I do not like about this scope, and maybe I'm wrong, but I don't see any buffer. You can't record anything and look back. You just have to kind of do it as you go, I guess. I mean, you just press the hold button when you got your signal on the screen. So let's do this again. I'm gonna get my key. All right, there we go. got ignition, so all right. And press. Nice. Okay. So this was a good capture. So you can see that I had to keep cranking the engine until I got my waveform on the screen, and then I press hold button. It's just the way this machine is set up. You don't have a buffer, and that's just the way it's going to be, I guess. I don't know. So now we can see this is our channel number 2. This is our sync, okay? And again, since we are looking at the voltage drop, we're going to look at the bottom part of the trace. And as we can see now, our sync, this is our ignition, and it's matching with the tip with the tip of the bottom of our trace here and here as well. Okay, so now again, you have to use your filter, because if you don't, it's going to be even more harsh in a signal. But now, so seems like actually that our cylinder number 2 is actually a little lower than other cylinders, but this is not a, you know, my engine is fine, but sometimes you have this noise, these peaks. Actually it's pretty much the noise, as you see when this the bottom trace, when it goes down, it kind of extends a little bit, but they can be a little bit confusing. Let's do this one more time to see if we can get let's see. Okay, all right. So this time you could see that now, like number 2 is actually a little bit longer, but this is again, this is just a little noise in the signal. But you can also look at the top of the trace. You can see it's nice and even. And but like if you also, this is very useful if you have a problem with if you don't know if your ignition is like if you have a problem with the jump timing. Okay, this is a nice test as well. You can see now you were pretty much dead on with our time. Now if you have a engine that's the jump timing, this sync on our ignition is going to be shifted a little bit, be retarded or advanced. So that's another test we can do with the rotative compression test. So I can see now everything's nice and even. This is a good engine, healthy engine. Now also, as I said, we triggered this from the coil for cylinder number 2, and our I'm trying to say, I'm sorry guys, I got a brain fart again. Firing order is 1, 2, 3, 4, 5, and 6. So basically, this is number 2, and then 3, 4, 5, 6, and 1 again. Okay, so we started from number 1, from number 2. I'm sorry, got 2, 3, 4, 5, 6, 1. So this is cylinder number 2, and this is cylinder number 1. So all the nice and even. And again, this is, you know, some scopes gonna pick up more noise, but if you have a cylinder that has a low compression, you will see there was going to be a significant loss of your amperage. I'm sorry, your voltage drop is going to be less in one of these peaks here. So I hope this makes sense. So now we're going to do the same test, but we're going to use a current clamp. And with the current clamp, you will see that our ignition is actually it's going to be at the top, because now with the current clamp, we're going to look at the amperage. So the amperage is going to rise as the mechanical resistance and the compression basically rises. So we're going to look these peaks to look our compression. So I'm going to set that up. So basically now what I'm going to do, I'm going to take my yellow lead, and I'm going to connect my current clamp and just put it around my negative or positive battery, negative or positive cable of my battery, and we're gonna read the current from it. So, all right, let me. Okay, guys. So quick look on my setup now. Now I have my current clamp on my channel 2. It's hooked up to my I'm sorry, on channel 1 it's hooked up to my yellow lead. So basically the black wire from our current clamp goes to black wire on our lead, it's a ground, and the red wire from our current clamp goes to the positive on your lead, and that's pretty much it. Now we're gonna turn our clamp on. Now the setting on this clamp, the 1 millivolt is equal 1 amp. So and of course my channel 2 stayed the same. I'm still triggering off the cylinder number 2, and all right, let's do it. Okay, so now we're going to turn the unit on. We have our current clamp ready to go, and I'm going to turn the lights on. My battery is getting weak, but I believe we can finish the test. So again, we're going to have this screen now. I don't have to go to my instrument setup to activate my filter. It's already done, so I don't have to worry about that. So I'm going back to my menu, and I'm going to scope. So scroll down to scope, press select, and I have to change my setting on my scope now, because I am using a current clamp, which it's going to be different settings. So I'm going to channel input A, the channel A. So now we're going to change this to DC coupling. We don't need AC. We're going to use a DC. Okay, and our for my voltage, I'm going to use a 50 millivolts. So I'm going to changing that. This way I go up. So 0.5 volts. Okay, and actually no, it's yeah. Okay, so I'm going to 50 millivolts on my setting, and I am going to be on let's see, 0.1 second on our time. Okay, 0.1 second, and now I have to set up my channel A. So channel A is a DC coupling, 50 millivolts, and 0.1 second. Okay, now my channel B, I'm gonna go back, and I'm pressing channel B, display on, DC coupling, and the setting is going to be the same as the last one. I'm using 5 volts. I have to change that to 5 volts. Okay, and the time is going to be the same. So now we can go ahead and do our. I'm going to crank the engine. And press the accelerator all the way down to the floor, and see what happens. Okay, so now we can see that these are our peaks on our now the trouble is with this scope, I'm not sure how to set my trigger. So we have 1, 2, 3, 4, 5, 6 humps, but let me see if I'm going to repeat this one more time. I would like to have this trigger on the side on the side of the screen, so we can see the whole pattern. Let's try it again. There you go. Here. All right, that's good. So it takes a while to, but again, I mean, I'm not. 100%. As I said, I had this scope for a couple of days now, but okay. So this is what we see. This is our cylinder number 2, and we got 1, 2, 3, 4, 5, 6, and that would be the same trace would be here. So basically, we can see all 6 cylinders, they're all nice and even, all the peaks are nice and even. And as I said, when we're doing a relative compression test with a current clamp, we're gonna look at the peak on top of the trace, and now we can see that our ignition is actually lined up with the top of our signal, our trace on from the current clamp. So all cylinders are nice and even. They're all drawing the same amount of amperage, which means they have all same amount of compression. So okay, I hope I covered everything that I wanted to talk, and this is it. This scope is okay. It just takes time to get used to it, but it's still very useful, and just need to kind of, not as good as, you know, I'm kind of spoiled having a snap-on, but this still can work. Well, guys, I hope somebody's gonna benefit from this. I hope that camera is gonna give us good detail on the scope, and as we could see that if you have a current clamp, it gives you better, cleaner signal for sure. And like looking at the voltage drop on AC coupling, sometimes you might get mistaken. Those little spikes, you would read that as a difference in a voltage drop and a difference in the compression. But you just kind of have to do it and get used to that signal, and you will be able to you know, figure out if you have any mechanical problems or not. So basically, by doing this, if you see on your patterns, you're supposed to be nice and even signal, and if there any discrepancy in your signal, then you're going to have a mechanical problem on one of the cylinders. And basically, this is all just to give us a quick direction. You know, if you have a misfire, this is going to give us a quick direction, what to do next. Should we go check in the... Now, when you find this problem with the relative compression test, then you have to go to your cylinder, and you do your compression check. You check your compression, and you figure out, you have like a do the leak down test to see if the valves are the reason why you have low compression, or the bad compression rings, or, you know, whatever the case may be. But the whole idea behind this test is just to give us a quick direction, and, you know, how to find our misfire, the reason for our misfire. So and this scope, again, it's a good scope, but it just takes a little time to get used to it. And I hope for you guys who have this, they can set it up. So now, if you have like 8-cylinder engine, you might want to have a longer trace, because I don't know if you remember if I had I think I did have 8 humps on the screen. So this setting, I think it'll work on 8 cylinders as well. So you just want to see all the repetition, you know, the signal from each signal from each cylinder, so you can compare it. So okay, guys. Appreciate you watching. See you next time. Thank you.